Hello friends and neighbors, Dr. E here. Jumping into the picture, let's jump right into the frame. We are working on advanced finance, the lazy mower. Sounds like my kind of mower. Maybe sounds kind of like my son, maybe the lazy. Oh man, put the hammer time on him. I'm gonna have to tell him about this. Anyway, so can you see me? You can barely see the top of my shiny dome. All right, so we are looking at questions 3, 4, and 5 in case 6, the lazy mower. So realizing that the chief investment, what does CIC stand for? I don't know. Anyway, will demand some kind of sensitivity analysis. How should Dan and Ron prepare their report? Which variables or inputs are obvious ones that need to be analyzed using multiple values? Explain by performing suitable calculations. So we did the scenario analysis in question 2, which is base case, best case, and worst case, where you change several variables at once to see what impact that will have on net present value and internal rate of return. Well, with a sensitivity analysis, we only change one variable at a time. And so as we look at our cash flows, I think the way we can determine which variables we should test is based on how significant the variable is in the context of the overall project. So let's look at rent. So rent is $120,000 a year, and our operating cash flow ranges from let's see, a low of $10.3 million in year 9 to a high of $15.5 million in year 3. Do you think that we should study rent? And the answer obviously is no. Rent just won't have an impact. In fact, I would argue that the $1.5 million in fixed cost is probably not large enough to mess with, because what we're talking about is a change. So if we take fixed costs down by 30%, that would be $450,000, okay, on roughly $12 million in operating cash flow. I don't think, and I don't think we could take fixed costs up or down by 30%. I would think 15 or 20% would be the absolute max. So we're looking at $300,000 at the max on operating cash flows of $12 million. It's just not significant. So what would make a significant difference? Well, the number of units that we sell, the price per unit, and the cost per unit. Those are the biggies in this case. We could even, if we looked at the $20 million, if we move that up or down by 15%, you're looking at $3 million over the entire project, which takes in base case $126 million in total cash flow. You think $3 million is going to make a dent in that $126 million in total cash flow? And the answer is no, it's not. So in this particular case, what we need to study would be the unit sales, the unit price, the revenues, not the revenues, I'm sorry, and then the variable cost. So let's take a look at that. So, and you know, I am more concerned about the downside than I am the upside. And so let's take a look, let's see what happens if we simply change our unit sales by taking them down by 15%. So we're going to multiply this times 0.85. Oops. Got to put equals there. Equals. Boom. All right. So once we do that, the way everything's lined up, all we have to do is scroll over to see what happens. And our net present value, it was 44 million. Now it's 28 million. Okay? And our internal rate of return is 45%. So we're still under the base case scenario, a long, long way from having a problem. Okay? So let's change that back. Now let's look at our price per unit going down by 20%. So equals 1,000 times 0.8. And let's go ahead and drag that across and see what happens. So we've taken it down 20% and our net present value goes to 26.4 million and our internal rate of return is still 41%. Not a problem. Okay? All right, let's see what happens if our variable cost goes up. And let's say it goes up by 20%. So we're going to multiply this times 1.2. And let's see what happens. Boom. Our variable costs go up. And our net present value 33 million and our internal rate of return 46%. So what this is showing us is that with this particular case, there would have to be massive changes in unit sales and or unit price and or variable costs in order to bring this thing down. So and we've done a worst case scenario here, 15%, everything that could go down 15% or could go up 15% to make it look bad happens, and you're still at 22%. So it would just take a massive problem for this project not to work. All right, let's look at question 4. How should the annual interest expense of $400,000 be treated? Explain. Well, the $400,000 is not an operating cost. It is a financing cost. Since our net present value takes the present value of our cash flows, if we included interest in our cash flows, we would be double counting our interest cost, because the cost of interest is included in our discount rate that we use to find the present value. So we don't want to double count it. Therefore, the $400,000 is ignored as a cash flow. You never use dividends or interest when you're computing your cash flows. Okay? For investment analysis, do net present value, internal rate of return. Now, using the base case estimates, calculate the cash, the accounting, and financial break-even of the lazy. Did you say bless you? I hope so. All right. Cash, accounting, and financial break-even. All right, so let's look at that. So, a cash break even is, the formula is you take your fixed cost less your depreciation, put it in the numerator. Then you compute your contribution margin, which is your sales price per unit minus your variable cost per unit, and you put that in the denominator. So, let's find, so we know that our fixed cost is equal to this plus this. All right, and let's go ahead and make it that, and take the cents off of it and center it. There's our fixed cost. Our sales price per unit is equal to, let's go ahead, let's go ahead and change this back. Shoot. Let's go ahead and change it back to what it was. All right. That ought to be good. Okay. So we're going to put equals this plus this, and then we're going to make it a currency and take the 2 off and center it, and we'll go ahead and put that there. Okay, and so the sales price per unit is equal to that, and variable cost per unit is equal to that, and the contribution margin is equal to this minus this. Bada bing. All right, and so our break even in units is equal to this divided by this. Bam, yeah. 2,700 units. Now, we'll go ahead and say this is year 1. And year 2 be the same. Years 1 and 2 are going to be the same, but let's go ahead and take it out to year 10. And what's going to change, the fixed cost doesn't change, but the price changes. So we're going to go ahead and drag that out there. And we're going to say that, let's see. Yeah, we'll drag this out here. And we'll go ahead and drag all this out. And we'll be good. Boom. So you can see that, let's go ahead and look at that. So you can see that when the sales price changes, then you've got to, we need to anchor this. So let's anchor this. Yes. Here we go. Okay. So we can see that when the sales price goes down, the number of units goes up. for break even. All right, so this is how many units we have to produce to break even. All right, now all of this stays the same. Let's see. So this number here equals this plus this plus this. Boom. That's accounting break even. It includes depreciation. So let's go ahead and scroll across that way. Okay. And then the sales price per unit is the same. So all this is going to do is raise the number of units we have to produce because it raises our fixed cost. And our variable cost per unit is equal to that, the 400. Let's drag that across. And then the contribution margin is the same calculation. So we'll copy that there. And this is the same calculation as well here. And let's go ahead and take the number of, take all those partial units off. And there we have it. As I told you, when you throw in the depreciation expense into your fixed cost, it just raises the number of units that you have to produce. All right, now the financial break even is equal to the fixed cost plus the rent plus the depreciation plus the $400,000 in interest. All right, and so let's include that. Let's see why that's going down. Oh, the depreciation is what goes away. That's what's happening. Let's look at the depreciation. Let's go here and let's take a look at the depreciation. I'm noticing here that our fixed cost, including depreciation, is going down. So I just wanted to make sure, let's look at our depreciation. That explains it. That the depreciation cost going down is what explains that. And then the rest of it should be the same. So we'll copy that. Let's see. This number. Something didn't copy right. Let's go ahead and put that there. Escape. And okay. Equals that. Equals that. All right, the contribution margin, I'm not sure. All right. Anyway, equals that. Let's go ahead and make sure that these are centered. And make sure that the format is good on that. And copy this over here as well. Boom, 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 and there you go. So, including the depreciation and the interest expense, that is the definition of financial break-even. So with accounting, let's go ahead and delete these, clean this up a little bit, maybe, yeah, we'll leave 2 rows in between. So fixed cost minus depreciation for cash break-even, fixed cost plus depreciation for accounting break-even, fixed cost plus, let's go ahead and change this, fixed cost plus depreciation plus interest here. So our fixed cost is the line that changes with each different approach, whether it's cash, accounting, or financial. The sales price stays the same, or the schedule of sales prices. The variable cost stays the same. The contribution margin stays the same for all 3 of these. What changes is what's included in the numerator. And under cash break even, depreciation is not in there, just your fixed cost plus your rent. Under accounting break even, your fixed cost plus your rent plus your depreciation. Under financial break even, your fixed cost plus depreciation plus your interest cost. And that, so your fixed costs go up under each of these approaches, and the number of units that you have to produce to break even goes up accordingly. Okay, so there are your 3 break-even analyses, and so we're far above break-even in terms of our forecast. Even our worst-case forecast, we're still way above break-even. So the break-even under the worst-case scenario, 11,530 units there, and we're still, what year does that happen? That's in year 2. So in year 2, we're expecting 29,000 units. So we're way above our break-even. So there's our break-even analysis, and it looks like we have